We good to go? All right, let's get started. So, welcome to the session. Typically titles of my sessions are probably too long, but it's MongoDB in the cloud: how to reduce infrastructure costs using open source components and Kubernetes. And when it comes to the cloud, I think it is also kind of nice, maybe extension of the keynote today from Peter Zaitsev a little bit. I haven't planned that, but this is how this is probably going to work out. But cloud in general gives us a lot of benefits, right? We can start building applications, deploying applications without detailed planning. We can pay as we go. We can scale when we actually need that. There are all kinds of services delivered by cloud providers and that we can use very easily. But the challenge is, and I think everyone agrees with that in many cases, cloud costs a lot of money, right? And from what I see, it costs a lot of money to run workloads in the cloud, especially when it comes to the data-intensive workloads and the databases, for many reasons. So that's why it's also super important to make sure that you have these costs somehow under control, right? That when you reduce the costs in that area, you can actually gain a lot. And this is especially important, I think, in the current, economical landscape where companies, organizations try to really cut costs and reduce the costs on multiple things. So my name is Michal Nosek. I am Senior Enterprise Architect at Percona. What I actually means that I work with our customers, with our prospects, helping them with their open source database adoption, including MongoDB related solutions. In other words, what architect does, I would say that I kind of sell options, but selling options doesn't actually mean that I sell options for money, but I am actually presenting different options to solve different problems. So whoever makes a decision can make a better decision for the specific circumstance. And I would say that the best part of my job is that I talk to multiple organizations in different parts of the world. So I meet a lot of smart people. I can try to learn a little bit from them, and then hopefully share a little bit what I learned with you today as well. And before I actually move on, I would like to ask a couple of questions. First of all, who runs MongoDB? All of you? Somehow, okay. Anyone using MongoDB Atlas, database as a service? Okay. MongoDB Enterprise Edition or Enterprise Advanced, if you will? Anyone using that? Okay, a little bit. And anyone running MongoDB on Kubernetes? Okay, well, that is good. So I think that's going to be useful for you. And who actually thinks, maybe last question, who actually thinks that cloud infrastructure is rather cheap and cost is not a concern? Nobody. Okay, well, that makes sense. So when it comes to the actual agenda, I divided the presentation in just like couple of parts. So first, we're going to look why costs with MongoDB in the cloud are getting out of control. So what are the factors that cause you to pay a lot for MongoDB-related infrastructure? And those are going to be different, like related to which type of service provider you choose, but also what mistakes are typically seen in MongoDB deployments that you need to overspend and over-provision. For those of you who don't know Kubernetes, and I assume that you don't really know Kubernetes, we're going to go through like 3, 4, up to 5-minute Kubernetes crash course, just for you to understand super high-level concepts, so you can then follow kind of the recommendations or approaches I am talking about when it comes to cost reduction. But don't be worried, like no advanced Kubernetes knowledge is actually needed here. And of course, we're going to look at some summary here. So first of all, why costs are getting out of control? Well, the first reason is what I call cloud DBaaS convenience fee. So, going with cloud database as a service with MongoDB, this is typically MongoDB Atlas, but this is actually applicable to other databases in general as well. You're going to pay a pretty high fee for the convenience that you're getting in exchange, right? Meaning on top of the cloud resources that you're going to pay for, you're actually going to pay extra for all the automation and all the management that is happening behind the scenes. The kind of challenge with that is that you actually pay for automation based on how much you spend on resources, right? So you have bigger clusters, this premium fee is bigger. It's not flat. It actually goes together with how much you spend on that. And having a quick look at a couple of price lists from cloud providers, you'll figure out that as I have here, a couple of cloud providers, so AWS, Azure, and GCP, and you can see MongoDB Atlas price for 2 types of clusters there. So 3-node replica sets, which is rather small, with 2 virtual CPUs and 8 gigs of RAM. In Atlas, this is called tier M30. And then another example, like way bigger. So I can show you, let's say, the trend that M200 is that I configured with 4 shards, 3 nodes each, and each 64 vCPUs and 256 gigabytes of RAM. If you look at those prices and you compare them to what you would pay at the specific cloud provider for, basically buying raw computing resources and raw storage in terms of EBS volumes in AWS and so forth, the difference is huge. And while with small instances, this difference probably makes sense to pay because it's a couple of $1,000 a year, depending, of course, of the scale of the organization. It starts getting less sense when you really have very big deployments, because if you think about what is the difference or extra you're going to pay on MongoDB Atlas versus the just pay-as-you-go resources from the cloud provider, you will see that this ranges anywhere between 100, almost 40% to 177% or 200% even in some cases. And this is true kind of regardless of the size, because this premium fee, this convenience fee grows with that. Moreover, if you have a look at what you can achieve with some commitment to the cloud provider, right? So basically buying some reserved instances for 3 years even, these numbers really get crazy, right? So 5 times more from what you are paying, for example, for MongoDB Atlas. And the problem with that is that you can't really get reserved computing power from cloud provider when you're running MongoDB Atlas. It doesn't count towards that at all. So, the difference is huge. But that's just one part of the story. Then when it comes to the way how easy it is to really run things in the cloud, it is in a way also a trap, because it doesn't make you try to fit your workloads into, let's say, the hardware that you have, but it's so easy to just expand it instead of thinking about optimizations, right? So cloud resources are virtually unlimited, so it's so easy to just add more shards, make your virtual machines bigger. It is pay as you go, so you typically don't have to plan that much in advance as well. And you need some massive 20 shard 5-node cluster with a couple of clicks. The number of clicks is the same regardless of how big or API calls how big you want the cluster to be. So it's a trap because it's so easy to get really up with those resources. And I also have a question to you as you're using MongoDB. What's the best tool to resolve MongoDB performance issues quickly? What are you using? Very good answer, I like it. Any other answer? Ops Manager, maybe somebody uses that, or some other things. Well, in my opinion, you are all wrong, because this takes time to use these tools, including PMM. But really, the easiest way, especially in the cloud database as a service, is to use the credit card, right? Of course, I'm simplifying, but basically what I mean is to, instead of resolving the core problems with how your MongoDB is deployed, to pay more. Like, it's so easy, like just scale up, or you have even auto scale turned on, so it can scale for you, and you'll pay more. So there are the problems that are typically resolved with a credit card, as I see that with my customers. So the common problem I see is over-indexing. So, we think indexes are good in databases in general, but they come actually at the price, and people tend to forget about it. So they create really too many indexes, which causes much more write pressure on your storage on every write. That's the one thing. But also what is often even more important, well, MongoDB tries to fit indexes always in the memory as much as it's possible. So you will not have space in memory to to cache your pages from the storage, but you'll actually use them for indexes, even for the indexes that you don't use that much. So over-indexing in general is bad for the memory usage, for the storage usage, and may cause significant performance issues. Then what you do is, let's get more memory, and for some time the issue is resolved. Suboptimal shard keys. Well, shard keys are difficult, and in many cases I see that they cause unbalanced shards, which basically means that part of your large cluster will take more data, more workload than the rest. And what you tend to do is to actually scale all the shards in the same way, which is probably right thing to do, but you should keep your shards balanced. And this is especially what you do with cloud database as a service as well. And then no data archival, right? MongoDB is good with a lot of data, right? It scales pretty well, so you can add shards. But in many cases, the data that is stored there kind of forever is not really needed, right? So it would be good to figure out the way to reduce the amount of data, so then you can also maybe reduce your working set and make it fit less memory. And MongoDB has also solutions to that problem, but we'll have a look at that later. So then once you're using your credit card to solve your performance problems, you actually need to, scale the instance, and that means go to a higher tier. And I have example here from MongoDB Atlas, of course, where we have in most cloud regions available more or less 10 production grade tiers. Some have additional options like NVMe storage or low CPU, so we have different ratio of CPU to memory. But in general, the rule is that whatever the jump you make, the next step costs pretty much double, right? So it's really, really expensive to, just add a little bit memory, because this a little bit is actually double, and you need to pay for that, right? So from M50 tier to M60, you have almost 100%. There's no M70, for those of you who don't know MongoDB Atlas. From M60, you go to M80, and this is, again, 85%. So this is really a trap from that perspective as well. And then also still talking about cloud database as a service, once you have everything prepared for you in terms of topologies, you can't really utilize different ways to reduce the resources that you need. So for example, you cannot differentiate the nodes that you have in a cluster. Like once you decide on 64 CPUs, it goes all the way across all the shards, across all the nodes. You can't use arbiter nodes, which is also, some people don't recommend arbiters, but I believe in some workloads it actually makes sense. And you can't run a single node, right? So in fact, if you even want to have some test workload where you don't really need a 3-node replica set, you still need to pay for that, right? And adding all this is really a trap. And we can go on with examples where things get expensive in the cloud, and especially in cloud database as a service, because data transfer costs, right? Many people complain about data transfer costs that come kind of out of nowhere, because this is not something you can really estimate easily for your cluster. They are kind of hidden and hard to verify. I mean, you are getting a bill, this was the data that you transferred, but then what can you do really about that, and why it happens this and that way? So understanding that your choices for how your topology looks like, and now this is true not only for Cloud DBaaS, but if you're using just infrastructure as a service as well, your choices where to put your nodes actually impact the data transfer costs also heavily, right? So it typically goes from it's free within the availability zone, then if it's between availability zone, you're paying more, then cross region, you're paying more, and if you're going over public internet, you're paying even more. But the impact of this, and by the way, it's super difficult to find the prices of those things, even if you try. But it can go from anything like 1 cent per gigabyte to 23 cents per gigabyte. And this is significant. MongoDB claims that most customers pay around 10% on the data transfer costs. But reality is, and I encourage you to look, for example, on Reddit, like many people complain, like, I have 2 gigabytes database, like how on earth I'm transferring like tens of gigabytes a month on this database kind of out of nowhere, right? So this is also a real concern. And the same applies to backups, right? You can do snapshots in AWS. I'm taking AWS as an example because this is the most popular. For 5 cents per gigabyte per month, or store things on S3 for even way less. And then if you look at the cost of backups on MongoDB Atlas, well, this is almost 4 times more for snapshots. And if you turn on point-in-time recovery, I mean, it can get anywhere from $1.5 per gigabyte to 40 cents, right? And it's so easy to turn point-in-time recovery, and many people really need that. But the cost can get really, really, really high, especially at scale, right? These things really matter. And then also how you configure your MongoDB cluster, like the common problems that I also see in the field is that for some reason people tend to configure a config replica set to like pretty big machines, but in fact you don't really need that. There is a lot of space to save some money there. And even if you look at MongoDB Atlas, they add just a small fee for config replica sets. So if you're setting up your own cluster in the cloud, you don't really have to put a lot of resources there. And of course, too many shards for the data set, as it's tempting to have this, nice, big and advanced cluster prepared for the future. So people tend to start with multiple shards instead of just scaling more as they go. Sticking to default parameters. And what I want to highlight is actually around how MongoDB uses memory, which is especially important in the scenarios where multiple MongoDB processes are run on a single host. And I see more and more people actually doing that, but they forget how MongoDB memory is actually, how MongoDB uses memory, right? Because there is one thing that you can control from MongoDB, which is WireTiger cache, where uncompressed data pages are actually stored. And by default, this is 50% of the available memory, right? Which is fantastic. And the rest, well, basically MongoDB relies heavily on the file system caching mechanisms. So basically compressed pages in the same way as they are stored on the disk will go to this part of the cache as they are needed. So in a well-balanced MongoDB system, reads don't really cause a lot of I/O operations on the disks because how this is actually structured. But what is happening when you run more MongoDB processes, then each MongoDB process will actually try to reserve 50% on the memory as well. So if you don't adjust that, you're in trouble because you will have basically different processes fighting for the same pool of memory. Hence, you will often need to go to disk to load that. But it's even bigger problem that you cannot control how those processes use file system cache, and there will be fighting for resources as well. So in general, the advice is, in most cases, don't do that without containerization, really. Yet I still see many people trying to do that. The kind of last piece of why our costs are getting out of control is, MongoDB starting as a open source or rather source available database, it provides anything you need to develop your application. At some point, if you're going to production, and especially if you need to meet some compliance security requirements, you realize that there are some features that are missing because you want to integrate that with central authentication system. Maybe you want to have a data at rest encryption with your keys stored in AWS KMS or some other central system. And for that, well, you have, I would say, 2 default options. One, you are buying MongoDB Enterprise license that will also make your costs pretty high, or you go with MongoDB Atlas. But even if you already consider MongoDB Atlas costs, you will see that turning on these features, again, add 15, 20% on top of your bill. And again, for example, enabling LDAP integration means 15% uplift on top of all resources that you consume, right? So you can easily see how much more in the end you may need to pay comparing to what you just think about resources that are already pretty expensive. And the worst, or one of the worst problems with all that is that once you land in cloud database as a service, especially a thing like MongoDB Atlas, there is no easy way out. Because once it's easy to import data there and even replicate the data there, there's no really easy way to replicate data out of MongoDB Atlas. Of course, we know why, but that is a problem that make people just spend more and more instead of rethinking options. So we're going to have a look quickly at Kubernetes and Kubernetes operators, because in general, the option that I try to sell to you today is basically think about taking your MongoDB deployments, use Kubernetes as your underlying infrastructure. You can get that from any cloud provider. Use Kubernetes operator that is actually going to cover for the automation part, and run MongoDB with open source components that way, because that can save you a lot of money. So, what is Kubernetes? Well, in a few words, it's a container orchestration system. Some people say it's an operating system for containers. But what that actually means is that you will have a control plane that consists all the components and APIs needed. And then you have worker nodes, which is basically pool of computing resources where this control plane can actually schedule your workloads. And those workloads are organized in the pods, and pods is nothing else as one or more containers as a unit that are kind of, you cannot separate them. So, for example, one node of MongoDB cluster of a replica set will be a pod. And in this pod may be, for example, MongoDB container with MongoDB process, but also some log collector or some metrics collector or some backup agent that will be other containers, and they will be together deployed as a pod, and you can never really split that within Kubernetes. But for simplicity, you may think about pod as a container. And Kubernetes has multiple kind of concepts inside, like replica sets. So, for example, the set of the same types of pods that are deployed separately. It will have persistent volumes, so basically storage that is attached to those worker nodes. Persistent volume claims how a pod requests a storage, so it can be attached to a container, and so forth. Important that you can get Kubernetes as a platform, because setting it up on your own can be a difficult task, and there are many moving parts, but you can get Kubernetes from really any cloud provider this way as a managed solution. And a good thing, by the way, about those managed solutions is that the price is really low and doesn't matter on the scale, right? So when it comes to MongoDB and Kubernetes, well, the problem with Kubernetes is that it was created for stateless workloads, right? So throwing your web servers there is pretty easy. You can kill the pods, you can move them easily, you can load balance between them freely, and so forth. That's not a complex task. But if you think about running a database, especially a database that was not designed for Kubernetes, like from scratch, there are many moving parts you need to take care of separately anyway, right? So you need to take care of the underlying Kubernetes. You need to have a separate stateful set for your primaries, replicas, config nodes, maybe routers, how you deal with high availability and what happens then, disaster recovery, the problem because Kubernetes kind of scope is always single region, how you roll out configuration and manage configuration, how you connect monitoring, how you do backups, and so forth and so forth. The thing is, you can do it, but this is difficult. And this is where actually Kubernetes operators come to the rescue to help you to deal with those things. So what is Kubernetes operator? Kubernetes operator is, well, basically two things. One, it's an application that actually runs in Kubernetes in a container. It will be always there. But it's also custom resource definition. And what is custom resource definition is basically extension of Kubernetes API. So instead of you as a person who wants to get a MongoDB cluster, or a developer that wants MongoDB cluster saying, oh, I need 3 pods of this type and the persistent volume claim and the stateful set and so forth, you can speak to Kubernetes in terms of, hey, I want a MongoDB cluster of 3 shards with 3 nodes in each replica set, and you deal with that, right? So basically, the application, the operator, will check Kubernetes API in a loop. It's a pretty simple concept. And whenever somebody puts some requests about, hey, I want a cluster, or maybe change the existing cluster, it will get that request, and it will start manipulate pieces in the Kubernetes in a way that it will create what you actually requested. So in other words, operator is something that understands both worlds, right? You, as a user of Kubernetes, want to use it more like a database as a fashion manner. Like, here's configuration, here's how my cluster should look like. And operator understands those terms, and it also understands what Kubernetes can do. So it kind of connects both worlds, so you don't have to know the details of how Kubernetes works exactly. And it actually goes further, because it's not, of course, only about deployment, because it is not only going to give you cluster you wanted, but it also automates day two operations, right? So it will take care of the backup of your cluster according to your needs. It will take care of the integration with the monitoring system. It will take care about self-healing. So what happens if one of the worker nodes are taken away, or there is some hardware issue, or a container dies? It will take care of rolling out the configuration and, for example, restarting MongoDB pods in an appropriate manner so you don't lose availability of your cluster. It will take care of the upgrade automation and many more things. Like, I don't know to go through all of them, but you can think about the scope of such the operator as similar to what database as a service automation is doing for you, with the exception, of course, that it will be doing that on Kubernetes. So how would you use it? And maybe it's a bit difficult to read, but the point is that you would use YAML files where you declaratively describe how your cluster should look like. And basically you will feed that to Kubernetes so operator can pick it up and can do the job for you. So, I have a definition of a cluster. It has many more options, but let's say this is a basic configuration where I have a name of my cluster. I have a MongoDB version here. I have, where my system user passwords are stored. I have a list or array of replica sets with shard1 with size of 3 nodes, and each node having 4 CPUs assigned and 8 gigabytes of memory. I want 30 gigabytes of storage. I want my config replica set to be configured like that, and I want one Mongo router. That's it. You describe that, you feed that to Kubernetes. Once operator is running there, you will get that, right? And of course, if you want 20 shards and you have enough resources, enough worker nodes available, it's easy. You can do that. You can also modify that, and operator takes care of it. So once we are here, let's have a look how this solution, so basically Kubernetes operator and running MongoDB on Kubernetes, can actually save you money on infrastructure. Well, first and foremost, as you need all those features that we sometimes call enterprise features, you should look at open source solutions. And kind of one of the solutions that is really important piece in all this is Percona distribution for MongoDB. For all of you that don't know, this is our software solution, the database server, actually a fork with a set of tools that we built on top of MongoDB Community Edition, where we add all those things that are typically expensive, but then we keep it with the MongoDB Community Edition license. I wish I could say it's open source. Well, our tools are open source, but the thing that we build on top of MongoDB is source available because we inherit SSPL license. But the bottom line is it's actually free. So in many cases, I don't want to say in all cases, you don't need to pay for this for enterprise license, for example, there. And then something about Kubernetes that is important, like really important conceptually to all the savings, is that any managed Kubernetes on any cloud provider comes at the cost of more or less $70 per month. And it doesn't matter if you have 3 worker nodes, 4 CPUs each, or you have 300 worker nodes, 64 CPUs each, right? The cost of management, like the control plane, is always the same. And it's not exactly 70, but to simplify, it's around that for all major cloud providers. And now, what is yeah, go ahead.
I'm interested on that, right? So, depending on the size of your worker nodes, you would think the cost would go up? No.
No. Each Kubernetes cluster costs around that. It's flat.
Like the control plane.
Yeah, control plane. And then you're, of course, paying for the worker node. So actual, yeah.
So the total cost of the cluster is still going to be...
Yeah, sure, much bigger. But what is important here is that at Kubernetes, you actually utilize what I call these raw cloud resources, like something that also that Peter mentioned in the keynote, that the cloud was like electricity, like utility, right? So you're not paying for all this automation and all these extra pieces on top of that, but you're paying for the cheapest cloud resources you can get. What I mean by that is that Kubernetes worker nodes are basically EC2 instances, and they, if in AWS, for example, and you pay for the EC2 instance that is your worker node, right? There's no extra service that makes a virtual machine a Kubernetes worker node. It is basically EC2. The same applies to storage. You're paying for EBS volumes in AWS, and it's the same for other cloud providers. So that is the kind of powerful piece here, that you're not paying premium on those resources because you can get them at the lowest possible cost for every cloud provider. And the same applies, to paying for S3 that is used by Kubernetes-based applications. And important, you can also pay your discount prices on that. So if you commit to some specific usage, maybe of a specific instance family, this all applies to Kubernetes. And not everyone is really aware of that if you look at the price list. But if you take reserved instances for 1 year or 3 years, you can get, for example, in AWS, up to 62% discount on that. Moreover, what is interesting, and maybe some people will think I'm crazy about it, is that you can use spot instances, right? Spot instances that can be useful even in production system that needs to be highly available. And when it comes to spot instances, well, this is like a diagram from EC2 console from US East 1 region that basically show, you can check there the historical prices of a specific spot instances in the different periods of time. And the question is how much cheaper? Well, in some cases you can get your computing even 80% cheaper comparing to standard dedicated pay-as-you-go. But of course you have to keep in mind that those can be really destroyed at any point in time. However, with a proper preparation, you can overcome this as a problem, right? So first of all, of course, it always needs to be clustered mode, right? So the database can fail over because restarting containers somewhere else always takes time, and you want your service to continue. Running in multiple availability zones, it also helps for spot instances because they tend, like the evictions tend to happen within the single availability zone. So there is a much higher risk of getting more instances killed at the same time if you run within the single availability zone. And also, you should use, let's say, less popular and less obvious instance types because they're in a smaller demand, so you can get better prices, and typically you don't lose these instances that often. But what is actually interesting is that within the single Kubernetes cluster, you can have a mix of dedicated and spot instances. So you can kind of find a balance between instances that will be always there and instances that, well, may or may not be there that you need to acknowledge, right? And that way you can also save a lot. It is also possible to configure Kubernetes in a way, for example, in AWS, where you will actually keep the balance of spot instances and the dedicated instances within the single worker node group. So you may decide, I'm just adding a little. And then maybe you will want to put your arbiter nodes pods there because you can also decide on that and don't let it be random and so forth. So there are many options that may help you to do that. Or in the simple scenario, like just put non-critical services on spot instances with the proper high availability measures as well. With all that, it is also important that you may use different instance types, right? So for example, in MongoDB Atlas, you don't really have a control over the ratio of the CPU to memory and what is the specific instance family, which comes also with a couple of other things. With Kubernetes, you have all types of resources in the cloud available, all families of the instances, all types of storage. You don't have that limitation. You have flexibility with that. And then the question is how to actually utilize that. So I have my large Kubernetes cluster where I would have a mix of on-demand instances. I would have a mix with spot instances that are pretty much ephemeral. I will have maybe worker node groups with a different size of instances or different families of instances in different regions. And like by default, Kubernetes will, treat them as a one pool of resources and throw the pods in a way that it actually makes sense currently according to some algorithms. But you're going to have more control over that. So you can, for example, use the labels that any worker node deployed to your Kubernetes cluster will get automatically. You can also create the custom labels. And then to say, for example, this MongoDB cluster I'm requesting, you can say in the YAML file, I want it to be only on spot instances, right? Because that's my choice, that this is lower availability. Or maybe I want to run it on R5 2x large worker nodes only, not on my other machines, because maybe CPU to memory ratio is better there. So you have control over that if you want. So if you have Kubernetes cluster or clusters with variety of resources, you may decide where to run what specifically, right? And then, as I mentioned, that every addition in the cloud, and this is not only for cloud database as a service, but also for infrastructure as a service, comes with double the cost for resources. So basically, from 4 CPUs, you're going to 8 CPUs, and from 16 gigs of RAM to 32 gigs of RAM with Kubernetes, you have much more control. And this is really powerful, how you can really adjust that, because you may assign as low piece of a CPU cycle as 1,000th of a CPU. Of course, in practice, you probably are not going to do that. But also with memory, you can go to, I think, even bytes there. You'll probably operate with megabytes, gigabytes, and so forth. But the point is, it is not a problem to have a node that requests 12.5 CPU per node in the replica set and 19 gigabytes of RAM, right? Why over-provision and over-consume if you don't really need that? So Kubernetes gives you that flexibility to actually add just a little if you need more memory, more performance, instead of doubling your costs at any point in time. And how you do that? Well, in every category of nodes that you have in a cluster in operator, so either just data nodes within each replica set or config replica set on MongoDB routers, you have this resources section where you set your limits and your requests. Now, not going too much into the detail what are limits and requests were, request is what you want to have guaranteed, and limit is what is a limit for Kubernetes control plane, which gives it the freedom to kill your pod if it overconsumes that, right? That's how Kubernetes works. And it's important for databases, in majority of the cases, to keep them equal, because that puts your pod, which is in this case my pods from shard 1, on the lowest on the lists of the order of the nodes that is going to be killed if there is a need for more memory or there is not enough memory and so forth, right? So it gives you a best chance to survive. And for databases, it's typically a good thing there. So now, with all this granularity and control, comes what I call kind of container Tetris. So to explain you the concept, like why the size of your worker nodes matter versus what are the container sizes that you actually run, especially on a smaller scale. Let's have a look at an example where you have 6 containers that needs to be scheduled. So you need resources for 6 containers in Kubernetes. One will need 10 CPUs. Well, 2 will need 10 CPUs, 2 will need 8 CPUs, and 2 will need 6 CPUs. And actually, if you take worker nodes that have, for example, 12 CPUs available, you will need, well, basically 5 of them. So you will need to schedule 48 cores, but you will need to pay for effectively 60, right? Now, if you reconsider your decision and you go with the worker nodes that are 16 CPUs, you will end up in a situation where you have to pay for just 48 cores. And of course, I simplify that because probably you're not going to end up in that clear situation, but it actually matters. And in many scenarios, having bigger worker nodes so you can pack more containers there is the way to go. And some people ask, what about resource isolation? The truth is, this is a problem that is solved in containers world for a long time, and Kubernetes is not reinventing the wheel. It will the wheel here. It will actually work pretty well with that as well. So you don't really need to be worried. And moreover, you remember the memory allocation problem that I mentioned. With this type of setup, the scope of memory that MongoDB process sees is going to be actually what is assigned to a container. So you don't have a problem of competing for the same space in the memory. For example, neither for wire tagger cache nor for file system cache here. Now, what is another powerful method to actually reduce the cost and keep costs under control, we have all this, is auto-scaling, right? We all have the workloads that sometimes require more resources, sometimes require less resources, and Kubernetes can be pretty efficient with that. So there are multiple methods to actually do auto-scaling. First is vertical pod autoscaler, which is basically looking at the utilization of the resources within your pod, and if it's enabled, it has a power to adjust that. So right now you have 4 CPUs, but your pod was consuming around 90%, let's say, about that for some time. The trend is you need more, so it will add, for example, 1 CPU to make it 5, not 4, to compensate for that. And in the same way, it can, of course, scale it down. Horizontal pod autoscaler, or the type of the autoscaler that is called KEDA, is about adding pods rather than resizing them. So it can actually query multiple data sources. So think about, cron schedule as a data source, right? Where it would actually, let's say, add nodes to your replica set automatically for weekdays, and then scale it down on the weekends because your workload doesn't really need those resources, right? Or it will query the MongoDB itself. Maybe you want to set it up in a way that your resources assigned grow with the size of the specific collection that is a concern because it needs to fit in memory or indexes sizes. Or it can query some Prometheus metrics, for example, like tons of integrations data sources that you may use for it to make a decision how many pods within a specific group of pods you need, depending on the factors there. And then that's just one piece of the puzzle, because the fact that you, let's say, reduce the container resources that you request is just one thing, but you still have your worker nodes that you are paying for, right? So the fact that they are empty doesn't mean that you are not paying for them. And this is where cluster autoscaler comes into play. So it will actually look at the resource utilization and how much of the requested memory and CPU are on the specific nodes. And what you can see in this animation, where the container, or actually a pod, is scaled down, it can move them between the worker nodes, then leaving some of the worker nodes empty, and basically terminating those worker nodes, so you don't need to pay for that. And based on that, you can really build powerful autoscaling. Also for MongoDB, depending on the situation they use. Because that's probably a topic for another talk, but I want to highlight possibilities worth looking at here. And then if you run MongoDB with the operator, you can also choose your topology freely. So for example, by default, operator will take care about high availability in a way that it will never put pods of the same replica set on the same host, right? By default, because that's not really high availability. But that's just a default, and this is achieved through anti-affinity. So here you see that I am using the label that is zone. So my worker nodes will have a label with the value of a name of availability zone, and pods within that group will never land on the worker node with the same value in the label. But you can also consider adding an arbiter, which you can't do with, for example, MongoDB Atlas. And you can also choose to put them all in single availability zone, because not in all the cases it really requires that level of high availability, not mentioning that it's also your choice to run just a single container to save on that. Moving forward, the last piece, I think, is storage. So Kubernetes introduces the concept of storage classes, which is basically different type of storage that your MongoDB cluster in this case will be able to use. And this is nothing else but AWS EBS in case of AWS that is going to be used. And if you just go ahead and don't specify any storage class, everything will work, but it will be GP2 storage, which is not optimal in many cases, and also a file system is going to be ext4, which is also not recommended for MongoDB. So it should be your concern and choice to define your own storage classes. So basically you can see here I put a couple of names, name bronze, and it will be GP2 with XFS file system. Then I created silver, which will be GP3 with 6,000 IOPS, and gold, which is more of a IO2 type of storage. But what is even here interesting and important, that instead of specifying provision IOPS that I have, I can specify, for example, depending how big is the volume, the ratio of the IOPS I want to have there. And of course, there's no limit on the number of storage classes that you may create. So that way, if you use these storage classes and you configure them in Kubernetes with the YAML files, you may then just say in your MongoDB cluster definition, I want this cluster to use gold storage class. And with 300 gigabytes and the configuration that I mentioned here, it will give you 12,000 IOPS. Yeah.
Does it go in and do the gradual change to modify storage classes if you need to go from silver to gold?
That will require actually recreating storage. You can't. Well, it will work, but it will basically destroy the pod, request new storage, wait for the initial sync of the MongoDB replica set, and then you'll have new storage. Yeah, that's the power of the operator as well. So you may, kind of dummy or stupid changes, and operator will make sure that nothing breaks, but it is actually modified in a way that is safe, right? The same if you change configuration or resources, it will not suddenly kill everything and then just do the change, but it will do it in a way that is safe for you.
Question on that. So basically the storage is attached to the worker node, correct?
Yes, it is EBS, yeah.
Yes. Or whatever it is.
Yeah.
So you will have to go through recycling each of those worker nodes to sort of, change the...
It is attached to a worker node, but it is attached to a specific pod. So once your pod gets scheduled somewhere else for whatever reason, because it doesn't maybe fit anymore, the storage will be reattached there as well. So I was just talking in the scenario where you change the type of the storage from between them. And also, because we are also slowly getting out of time and I want to wrap up, is there is also NVMe storage that is available in Google, in AWS, I'm not so sure about Azure, where you actually can get a lot of IOPS and a lot of storage for very decent price comparing to what it would be with EBS volumes, right? So, for example, i3 instances with, let's say, 32 CPUs and 244 gigs of RAM come with 4 disks of almost 2 terabytes NVMe, and they are more than 1 million IOPS of reads and write. And what you can, for example, deploy with EBS, I'm just putting that as an example, with 64 IOPS, costs just many more times more, right? And of course, and you can use these drives in Kubernetes, right? But of course, you need to be careful again because NVMe storage is ephemeral. So when the node dies, when actually the worker node is terminated, you will lose the data that is there, and you cannot extend its size. So once the instance type comes with 4 disks of almost 2 terabytes, you can't extend that. It is a good way to reduce the cost where you need very fast storage. And you can actually overcome the challenges with the nature of the disk that is ephemeral with actually, again, high availability, with some extra solutions that you may install for Kubernetes to manage those storage, like OpenEBS, which is also open source solution. And of course, using right concern in MongoDB properly. But the performance of this storage is unmatched, and also price of those nodes is unmatched with anything else. And maybe flying through that, like stop solving issues with credit cards, especially on the scale. It really matters to check index usage stats, to consider things like partial indexes that not everyone know about really, where you have a large collections, but only subset is important to be quite quickly. You have now ability to adjust the sharding keys in a way easier way in the newer MongoDB versions. But also for data archival, you have built-in mechanisms like capped collections, where it will depend on the collection size, where the oldest data is deleted, and also time to live indexes that will help you to keep control on the data size as well. And, as a summary, I would like to encourage also everyone to understand the workloads better, which is sometimes difficult, but especially important for large clusters. So if you use Percona operator, you can basically with, 2 commands install Percona monitoring and management on Kubernetes using Helm charts, and you can just tell your MongoDB that you deploy where is this MongoDB actually located, and without any extra integration, you can start consuming metrics there and also get insights into PMM. So in the second position after credit card, PMM is great to approach that as well. You will be able to look at the queries and the queries that are consuming the most resources, but also have a look at underutilized worker nodes and containers that are maybe good candidates to scale down even without that. So to sum up, as we're out of time, getting this convenience and automation in the cloud typically comes with really extra cost. You can use open source to not pay for those features that you normally consider to be like in the enterprise space. And there are many areas where you can fix your configuration better. And when I talk to our support engineers, they're like saying, give me any MongoDB cluster and there's a good chance you'll be able to save 30% if we configure that properly, because in many cases people stick to defaults. And as a final thought, and maybe answer, like what is the potential for this approach, how much money it can save to you? Well, I don't like to promise anything, but I was participating in the projects where we saved more than 50% of MongoDB Atlas costs pretty easily for one of the Spanish telco providers. So Atlas overrunning MongoDB on Kubernetes this way, and we're yet to start the actual optimization of the workload. So it was more like lift and shift so far. And I think that's it. So thank you very much. Any questions?
Does the operator today of MongoDB is running?
What MongoDB version? Well, there is a pretty much latest 6.0 available. So it typically takes a couple of weeks before it's available, like images for that. But yeah, it is running the latest version. But keep in mind that the operator version and MongoDB version, those are separate. So those are not the same. Yeah. Okay. Thank you very much. Enjoy the rest of the conference.